Hi, everyone. I'm Julie McKenzie. I've been with Advanced Instruments for about 16 years now. My background is in biochemistry, cellular, and molecular biology, and very excited to demonstrate the GloCyte for you today. Before we do that, I want to give you a bit of background and have a few slides to share, and then we'll hop right into the demonstration. Okay. So hopefully everyone can see and hear me okay, or see my slides okay in just a minute here. All right, I do have my wonderful colleague, Adrienne, who's monitoring the chat. So feel free along the way to ask any questions that you may have. And we'll be happy to answer those both during the presentation through chat and at the end of the presentation, either through chat or live. So first, I just wanted to introduce our company, Advanced Instruments. Hopefully, some of you have heard of our name, but if not, really wanted to just share our mission, and that is to deliver innovation that optimizes processes and increases efficiencies. It's all about making sure that the laboratories have confidence in results to improve outcomes, because at the end of the day, we're all here to support the physicians in treating patients and ensuring they have the best possible outcomes. We are headquartered here in Norwood, Massachusetts. Not sure where everyone is right now in the world, but today in Boston and Norwood, we had a solid sheet of ice on the ground, so some frozen rain. So our weather here in Boston keeps it interesting. I am very much looking forward to the spring. We at Advanced Instruments, we were founded in 1955, so we've been around for quite some time and really focused on continuing to deliver innovation to laboratories like yours. All right, so before we dive in here, wanted to give you a little bit of an overview of our clinical instrument portfolio. And maybe while we're chatting, if you recognize any of these systems and you have them in your labs, love to see you drop a note in the chat based on what product you have. We serve several benches in the laboratory: chemistry with our osmometer product line, really taking 100 possible diagnoses and reducing it down to a dozen to help the physician figure out what's happening in the patient's body with an osmolality test. We have our Inoximat anaerobic jar system in microbiology to really quickly and accurately create custom environments to grow your anaerobes and microaerophilic bacteria. The GloCyte, which we'll talk about today, you'd find in hematology. Really, we've found a way to automate spinal fluid cell counts. So excited to talk more about that. And then lastly, our bilirubin stat analyzer. So for your neonates, being able to measure both total and direct bilirubin very quickly and very accurately. So drop in the chat. Do you have any of these products already? All right. So next, let's talk about the importance of cerebral spinal fluid analysis in cell counts. CSF is an extremely crucial body fluid because it holds the key to unlocking diagnoses involving the central nervous system. CSF is the fluid that bathes our brain and spinal cord, and it can tell us a lot about what's happening with the patient, from infections like meningitis to malignancies like leukemia. These aren't, insignificant things. If someone has something like this, we absolutely need to know right away so that we can treat them. Typically, spinal fluid is collected by a spinal tap or lumbar puncture, although there are many ways to collect a spinal fluid sample, a shunt, for example. And typically, multiple tubes are collected because they're often sent to various benches in the laboratory. It's really important to analyze spinal fluid quickly because as soon as you remove cells from the patient's body, they start to degrade. And so you probably know, being in the lab, spinal fluid sample comes in, you drop everything because you need to count that specimen so that it's accurate. That's why often you won't find spinal fluid samples as a send-out test and cell counting, because you need that result so quickly. Cell counts are a really important part of spinal fluid analysis. The total cell count, which is what we'll focus on today with GloCyte, provides a total number of red blood cells and a total number of total nucleated cells in the spinal fluid. CSF is unique with other body fluids because it has very low cell counts, and that becomes really important in terms of the method you use to analyze them. So let's talk about some benefits and pitfalls of traditional cell counting methods. But before we do this, some of you may recall the dress debate, and I'm curious to hear from everyone if you can put into the chat, do you see white and gold with this dress, or do you see blue and black? If you can go ahead and share your answers in the chat, I promise this is relevant for our discussion. Like I'm seeing a lot of blue and black responses. I'm on team white and gold, and I will tell everyone what the right answer is, the actual colors of the dress. But we'll just give just a second here. It looks like we've got most folks answering. And yeah, it does look like it's blue and black for the win. So I was surprised when I looked this up. I thought for sure it has to be white and gold. I know I'm right. Well, it turns out this dress, the person actually wore to a wedding, is white with black lace trim. So, or sorry, blue rather, with black lace. So if you guessed blue and black, you are correct. White and gold, we are not correct. And what that does is it just shows the subjectivity of someone's visual interpretation. So I promise, like I said, this all applies. And so the reality is that with traditional manual methods, like cell counting, using a microscope and using a hemocytometer, they rely on a person's visual assessment. My visual assessment, white and gold, was very different than my colleague's visual assessment. For example, John on this call, he saw blue and black, right? And the same is very true of anytime you're using your eyes. And those eyes are probably stressed because I don't know if I've ever met someone in the lab that, isn't running around, right? We're all running around. We have so many things to do, and then we have to sit down at the microscope. And I won't go through each of these steps, but you can see on the left all of the steps that go into the manual method. And there are some of these that, we might rush through. For example, waiting for cells to settle in the chamber. And every cell matters, whether it's a low cell count or a high cell count. So there are many different risks that could impact your result accuracy. So red cells and white cells, maybe not white and gold versus blue and black, but hopefully you get the idea. Historically, what's happened is that commercially available automated analyzers have been really designed to perform accurate cell counts on high cell count fluids. So that's important, right? Blood, for example, we absolutely have to have those accurate counts. What's unique about spinal fluid, as opposed to other body fluids, is that not all, but many spinal fluid samples have very few cell counts. If we remember back to our reference ranges, you really shouldn't have red and white cells in your spinal fluid, unless perhaps you're an infant, and then you have a few until you age a bit. So really low number of cell counts, they are typically problematic on automated analyzers. But that is really until now with GloCyte. So I'm going to stop sharing my screen for a moment, and hopefully you can see my screen pretty big. Maybe, Adri, do you mind just confirming for me that you can see the GloCyte on the screen?
I can.
Thank you so much. So what I'd love to do is show you the instrument. And so first, showing you how small it is. I have not been in a laboratory where there has been a ton of space. So one of the things we had in mind was having an instrument with a really small footprint. So you're looking at it here. Yes?
Sorry, we're a little bit out of focus on this one.
Let me see if I can adjust the focus. Thank you, Adri.
You're welcome.
Let's see. How is that?
Perfect.
Okay, great.
Thank you.
Thank you, Adri. You're the best. So this instrument is really the size of not even a Keurig coffee maker. Really small, fits anywhere in the lab on your hematology bench. And what we've done, if you were here with me in the room and you could look under the hood, is we've essentially automated the cell counting process. So what you'd see is you'd see a microscope objective, you would see a light source, and you would see a camera. But that's it. The design is robust in that there's no fluidics, there are no tubes, there are no moving parts. Maintenance was something that we really kept in mind when we were designing this system. Who wants to be on the call with a vendor trying to get maintenance for their instrument? We didn't want that. So we designed this really robust design. Sitting next to the GloCyte is the vacuum station. And I'll show you that in a minute, but it pulls spinal fluid through a test cartridge to capture cells on the membrane. Okay. We also have our sample preparation tray. Here's where you'll put your spinal fluid samples. We have our reagents because we have a red cell reagent that stains the red blood cells. It is an antibody stain that tags the antigens on the red cell surface. And we have a white cell reagent, a total nucleated cell reagent that has a detergent that punctures holes in the walls of the membrane, allowing the nucleic dye in to stain that cell. We also have our test cartridges, and that's really the magic of this system, and I'll show you that in just a moment. And then we have our low and high controls for our daily QC. So the procedure is really simple. What we do is we take 30 microliters of our spinal fluid sample, and we dispense that into each of 2 tubes, one for the red cell test and one for the white cell test. And then we simply add our reagent to those tubes. So it's a fixed volume, so no worries about having to dial in any pipettes, all fixed. So I'll add my 30 microliters of red cell reagent to that tube. Because it's an antibody stain, there is a 3-minute incubation. So we will go ahead and let that assay incubate. And we'll go ahead and run the white test. So adding that sample and reagent together. And then we'll just go ahead and simply dispense that onto the test cartridge. Okay. So we'll take this test cartridge and we will move it over to our vacuum station. All of the spinal fluid is pulled through the membrane, essentially acts like a filter, capturing all of the cells on the membrane. We'll put that cartridge into the instrument and we'll run our test. We do have a barcode scanner. For now, I'm just going to put in any type of accession number. You can note if there's a dilution in the appearance and color of the sample, what source it's from, and we'll start our test. So at that moment, we take an image of the cells on the membrane. And right there, you have your beautiful starry night, all of your cells counted, 11 cells per microliter in this case. I'll accept my result and remove the cartridge. It's really that simple. And just to go back to that image for a moment, what you're seeing, those green markers, are tagging all of the cells to give you that total white cell count of 11 cells per microliter. You're probably looking at that image saying, well, Julie, there are way more than 11 cells there. How does that happen? So the system knows the volume of sample that's put on the cartridge, so it does the math for you. And if you had made a dilution, because let's say you had a bloody or a pink sample, it would factor that in too with the dilution factor. So all of that math is taken care of. It's not that we can't do the math, but why should we have to? Let's take that burden off of your team and put it on the instrument because it can do it so quickly, all right? And the red cell test would be the same, identical. And so just showing you again what that looks like. We have our sample that's been incubating for 3 minutes now. And it doesn't need to be exactly 3 minutes. It just can't be under, but it can be over, up to 15. And we'll dispense our sample onto that test cartridge. we'll move the test cartridge over to the vacuum station. And again, we're pulling all of our spinal fluid through the membrane. We'll put our test cartridge in the instrument. And essentially, we'll just take a picture of the cells hanging out on that membrane. Okay, so we'll quickly snap a shot and get our cell count, in this case, 8 cells per microliter. And let me share that with you so you can see my screen. So really quickly, you have those results. And so the idea here is that you can get both your red and white cells in under 5 minutes. Okay. So now what I'd like to do before we take questions, I would like to show you a case study that we did and pose almost a challenge for the team to consider. All right, so I'm going to go back to my deck here. Hopefully everyone can see this. So wanted to share a bit of a case study. So we have a customer who, they have about 550 beds, and they're a teaching hospital in the US, and they brought GloCyte into their laboratory. And they thought, let's do a serial dilution study. Let's take a look at serial dilutions for GloCyte and serial dilutions for the manual, taking a more concentrated CSF sample and diluting that with saline. And so they did that, and based on the dilution factor, you can see what you should get in terms of your results, right? If you do a 1 to 10, should get about half, and again, et cetera, right? Same for manual. So what they did then is they said, okay, let's count these samples that we've made on the GloCyte, and let's count them manually. And what was really interesting is you can see that the GloCyte follows the trajectory you would think, right? Your 1 to 10 is about half your 1 to 5, and et cetera. But with the manual method, that wasn't the case. And in fact, their 1 to 20 dilution was higher than their 1 to 10 dilution in terms of the cell counts. Shouldn't be the case, right? If anything, it should be lower, and it should be half. So what this demonstrated, this was really an aha moment where taking that variability and taking that visual subjectivity and also taking the burden off of the techs, right? Coming into the workforce, whether you've been there for decades or maybe someone new in the lab, taking that burden off of the tech and using the automation and the technology like GloCyte that exists to feel confident in those results. So I would love to say, you don't have the GloCyte to do that part maybe in your labs, but I would love to have everyone on this call go back to your teams and say, let's do a manual cell count challenge. And let's do some serial dilutions with a CSF sample with, doesn't have to be hugely high counts, but around 200, and dilute that using normal saline. Have your staff perform those counts on both the neat and diluted samples and compare your actual results to expected results. And I'd love if you'd be interested to share those with us or to have a conversation with us, because we'd love to talk about ways that we can help you increase confidence in those results. So what I'd like to do now, I know my colleague Adri has been monitoring the chat, but I'd love to answer any questions you have. And I'll go back on screen so you can see me again. Adri, any questions coming through?
There was question, but I have answered all of them, I believe. I'm sorry if I did miss out one, but I don't think so. We had question about linearity, some dilution, so I answered all of those. Someone is asking about QC. Stacy, are you asking if QC are necessary and when to run it, high and low? Yes. Julie, do you want to give some information about QC?
Yes, sure. So first, even backing up before QC, it's worth calling out that there's no calibration with this instrument. Doesn't exist, which is really nice, but there is quality control and it's very easy to run. So with the quality control, you want to test your low control and your high control at least once a day per cap, and ultimately it goes to your lab's guidelines, but the low control has both fixed white and red cells at a concentration of about 12 cells per microliter. And the high control similarly has those fixed white and red cells, but a higher concentration, closer to 120 cells per microliter. We recommend running those at least once every 24 hours, along with your saline if you're going to be doing any dilutions. And I've seen labs get creative with this. Some laboratories will have first shift run the diluent, second shift run the low control, and third shift run the high control, for example. So we absolutely have recommendations and can support you, but ultimately, you can set your best practices, and we're here to support. And maybe while we're waiting to see if there are other questions, along the same lines of QC, we often get asked about proficiency testing. And CAP has an automated body fluid survey, ABF-1, that can be used with the GloCyte. And with that, you'll be able to see the peer group of other users and see that count number and be able to compare your results to the peer group. All right, any other questions? And feel free to, you can drop them in the chat, you can come off mute. I'm curious to hear also if you're willing to share either verbally or in the chat, what is everyone doing right now for counting spinal fluid samples? Are you doing manual cell counts? Are you using GloCyte and just checking in to see?
Stacy is saying manual.
Okay.
Manual. Sysmex and manual. That's a combination we see a lot.
Absolutely.
We
Yes.
have a question from Connie. What is the required maintenance?
Sure. So required maintenance is very simple. We do recommend an annual preventative maintenance visit with someone from our team who comes on site to inspect the instrument. But for user maintenance, this is the easiest thing to talk about. So the vacuum station, there is a O-ring inside the vacuum station that you simply replace every 6 months. It pops in and out pops out with a pair of tweezers, pops in with your finger, and you're done. That's your maintenance. Really, it's running your quality controls. And then, of course, with pipettes, you do want to have those calibrated with your annual cycles. For example, our TEL PCS system can be used to perform on-site pipette calibrations. So that's an option as well. But little to no maintenance, which is very easy. Okay. In terms of, it sounds like a lot of people doing manual cell counts. I'm curious, how many are you doing in a given day or week? Are you doing just a few or doing very many? It's interesting. I'd say we have customers, some are doing many, many. I can think, or even our highest volume users might be 50 or 60 a day, down to there's one customer I can think of that has one a year. And, it's such a discrepancy, right, between the numbers, but it's interesting. For the high volume labs, it's about how do I maximize time, improve turnaround time, and get these results out, as quickly as I can and as accurately as I can. And then for the low volume labs, it's more, we don't see CSF a lot. So when it does come in, it's a little bit like, oh, right, I have to do a CSF count. And GloCyte really just alleviates that, that stress of, okay, let's pull out the manual, right, and doing that CSF count. So we see a wide spectrum. And the other thing, I know that there was a comment about a laboratory that is using manual cell counts and an automated method, probably for the higher cell counts. One thing that's nice about GloCyte is it allows you to streamline all of your cell counts on one instrument for CSF, rather than splitting it into, doing clear and colorless on manual and the bloody samples on Sysmex. So hopefully that's a helpful tidbit. All right. Any other questions? I'm curious too, what are your, and I know it's, is short, but what are your thoughts? How have you heard about GloCyte? Did you hear about GloCyte for the first time from our email communication about our Deminar series? Did you hear about it from another hospital? Curious to know how you heard about the system.
So while people are answering, we do have a variety of answer in terms of how many CSF. We have some
Okay.
people doing once a month. There's 30 a day, which is a
Oh, wow.
lot. And Stacy is saying that their numbers is increasing, so there is a potential for
Oh,
them to maybe look
interesting.
into this. And a lot is email. This was the first time I've heard of it. I learned from the email demo. Adam sent demo at another hospital, so we've seen it in action. A lot of people are saying through email, so various communication.
Great. That's super helpful. All right.
Julie, there was a question about dilutions. I'm curious if you could maybe show an example of how the GloCyte recommends a dilution through that sort of testing scheme. Thank you.
Yep. Let's do that. So what I will do is, hopefully you can see my screen. I'm just going to log back in here. Okay. So let's just say there is a case where you may have a bloody sample or a pink sample. You just know it's going to be cellular. You know you'll need to make a dilution. You have guidance right on the screen that before you run anything, it shows you how to make the dilution, and not just what dilution to make, but what are the volumes. And just like doing the math of the cell counts isn't, it's not hard to do the calculation, but you shouldn't have to do that, right? So if I tell you, 1 to 10 dilution, I want to tell you exactly how to make it and support you through that. If, though, however, you were to just run your sample neat, you could do that by simply putting in your patient accession number, choosing your cell type. Let's say we start off with no dilution, and maybe the sample is, let's go with bloody for now, bloody and pink. And our source is, let's say it's tube 1, and we start our TNC test. So this is an example, actually, I should say this is probably clear and colorless. This is kind of the happy path where it gives us our answer right away, 46 cells per microliter. But maybe we need to do a dilution, and we have a sample this time that's bloody and pink. And we'll actually get a dilution recommendation from the instrument. So you don't have to look through the microscope and say, all right, a lot of cells here. Am I doing 1 to 10? Am I doing 1 to 100? The instrument actually analyzes the image that it's taken and, within a split second, gives you the next step. A 1 to 10 dilution is suggested. And it tells you how to make that 1 to 10 dilution. 90 microliters of your diluent, which is normal saline, and 10 microliters of your sample. So you'd simply make the dilution, run your test, and you would choose start. And very quickly, we get our count of 473 cells per microliter. Again, that math is incorporated into the system, so you don't need to jot that down. And you don't have to, but there is the capability of connecting the GloCyte to your LIS. And so if you do want to avoid the manual part of entering the result, that's also an option. Does that help answer the question about dilutions?
Yeah, wonderful.
Awesome.
Great job.
Thank you for flagging, John. All right, so I recognize we maybe are close to time, and I want to be conscious of your time. Adri, any last-minute questions in the chat?
Yes, so I answered the one about LIS. Just to be clear, it connects to most LIS that are out there. And someone asked, can the results be print out? So I know we do have a thermal printer. Julie, do you want to kind of talk about a little bit about the printout report?
Sure. Yeah, we don't necessarily actually have a dedicated printer for GloCyte. I've seen laboratories connect it to either a standalone printer or a network printer. Either is absolutely fine, and there is a printout for each result should you choose to use it. I will say that I don't typically see people printing out the results per patient. I do see sometimes people exporting their results, and I can just show you what that looks like. So what I will often see is, let's just accept this result here. So under Let's see, our results. We have our results table, and we can export those results. We can do a print preview, print report, or export this and print the result or create a new database. But I'd say typically I don't see people print. However, you can absolutely do that. Multiple ways to manage the data. Another neat thing about GloCyte, just while we're talking about results, is the audit table. So all results that are rejected are saved to a database for audit purposes, inspection purposes. So you have a full audit trail on the system with timestamps, which I know people have gotten dinged before with manual cell counts as that timestamp. We've got you covered there.
Thank you very much, Julie. So Stacy was asking how long do they store results? So it's not so much a question of time, but number of points, data points. So we usually recommend, clearing out your data set after when you're getting close to 10,000 results. Julie, did you have any more information about that?
Sure. So let me just share the screen again. So really simple on the bottom of the screen, and it's actually hard to see here, but on the bottom of the screen, it will tell you how much space is left in the database. And when that starts to get full, you'd simply do File, New Database, and create a new one. So there's really not even any need to clear anything out. It's just creating a new database, and your existing databases will be stored if you ever need to reference those. All right. Anything else, Adri? Are we caught up with chats?
I think we are caught up. I'm not seeing anything else.
Okay. Well, I just want to say thank you so much for everyone for joining today. I know how busy you are, and the fact that you took time out of your calendars to come check out the GloCyte. Truly appreciate. I'd love to continue the conversation and hear how that challenge I gave you goes with the serial dilutions and continue that conversation both with my colleague Adrienne, who's online, as well as Maria. Both are tremendously valuable resources, and we'd be happy to chat further about GloCyte. So always just a phone call or email away. I hope you all have a wonderful week, and I hope you are someplace warmer than Boston with the ice and the snow. And yes, just thank you so much for joining.